All right, we're going to be doing chapter 1. And the discovery process for chemistry, what are we talking about? Chemistry is the study of matter, its chemical and physical properties, the chemical and physical changes it undergoes. As matter undergoes changes, it gains or loses energy. Matter is anything that has mass and occupies space. So really everything is matter. Even air is matter. You can weigh air and it occupies space. So really what all of chemistry really boils down to is we have a bunch of stuff. We take it apart. We come over on the other side and put it back together in a different arrangement. That's all really a chemical reaction is. And to do this requires energy and it releases energy. Sometimes it requires more energy than it releases. Sometimes it releases more energy than is required. That breaks it down in about a nutshell what's going on. And energy is the ability to do work to accomplish some change. What is the role of chemistry? Well, obviously, I told you I worked in the pharmaceutical industry. A big role in the pharmaceutical industry, we made drugs. I used to get a kick out of telling people, what do you do for a living? I make drugs. Okay. Public health. Okay, you're dealing with STDs, AIDS, Ebola virus, different infections, flu. All comes down to chemistry. Food science. What's going on in food science? Everybody see this new stuff in the store, Beyond Meat? It's in the store. It's Beyond Meat. It's meatless meat. I don't know what meatless meat is. It's vegetarian meat. And before you only had tofu. Now apparently this is something that's made from vegetables that supposedly tastes like meat. I haven't tried it yet. Forensic sciences. I mean, anybody who's ever watched NCIS, any of those programs, there's always some weird-looking person in the lab that's able to look at different things. When I was in the pharmaceutical industry last 15 years, I was kind of that person. I did the troubleshooting. I ran a microscopy lab, so I would be looking at all the different problems that came through and trying to figure out where stuff came from and what was causing the problems. And of course, medical practitioners. I'd like to extend that and say, well, chemistry has a big influence on our social norms. If nobody here is probably old enough to remember, but the 60s, the birth control pills came out in 1949, but became readily available in the 60s. Of course, that led to a certain revolution during the 60s. And part of science is called the scientific method. A systematic approach to discovery of new information. You probably have all had that sometime during elementary, middle, or high school. Characteristics. What usually happens is an observation. You observe something. Then you ask yourself a question. Why does that happen? You look for pattern recognition. Does it always happen this way? You develop theories on why it might happen, or a hypothesis. You do an experiment or experiments to prove your hypothesis. You collect data. You look at the results and you summarize the information. So you observe a phenomenon. Question is why or how something happens. You propose a hypothesis, which is a potential answer. It's not always the right answer. You conduct experiments. You analyze the data and results. If it supports it, you can formulate a theory. If it rejects it, you can come up with a new hypothesis. And you repeat the process. You know, the history of science has a lot of erroneous observations. People, the theory of spontaneous generation, life come about spontaneously because people would see meat left out on the table. Next thing you know, they'd see maggots. Well, where'd the maggots come from? They just spontaneously generated. Well, that was the hypothesis until they did experiments and they left meat outside. And they had meat outside they covered with glass. The one that was covered, no maggots. The one that wasn't covered, maggots. And of course, they found out that flies laid their eggs in there. So that disproved that theory. A lot of times you can do experiments, and of course, you know, the phlogiston theory is a similar thing, that there was something magic in the air that kept us alive, phlogiston. And that led to the discovery of oxygen. But just because you do a set of experiments, sometimes it can lead you to the wrong conclusions. So here's this biologist, he has this frog, and he trains the frog to jump when he yells jump, so the frog jumps. So one day he anesthetizes the frog, cuts off one of his legs. Next day the frog's healed, he yells jump, the frog jumps, kind of lands kind of funny because he only got 3 legs. So he anesthetizes the frog again, cuts off a second leg, and yells jump, and the frog kind of jumps. Cuts off the third leg, and he yells jump, and the frog kind of barely comes over. So cuts off the fourth leg, and he yells jump, and the frog just sits there. He yells jump, frog just sits there. So he looks at all his data, and he comes to the obvious conclusion. When he cut all 4 legs off the frog goes deaf. So just because you look at you could read data wrong. Now in chemistry, we use models a lot to represent things that we can't see. To look at help with our understanding. This is a ball and stick model. For those of you old enough to remember Tinker Toys, this is kind of what that looks like. This is methane, CH4. We have color-coded. There's no color on these but usually carbon is black and hydrogen is white. And until recently, we couldn't see atoms. We can now see atoms. So going back to talk about matter, how do we classify it? We classify it by properties. The characteristics of matter we can use to categorize different types of matter. We can classify it by state or by composition. The 3 states of matter, you all know them: gas, liquid, and solid. So we talk about gas. The particles are widely separated. Gas, there's no definite shape or volume. I don't know what the solid, no volume, no definite shape or volume. That's all you need to know. So the particles are far apart in a gas. And there's no definite shape to it, and there's no definite volume. Someone drops a bottle of perfume in the back, I'm going to smell it up here. It just keeps expanding. A liquid, particles are closer together, definite volume, but no definite shape. So 2 liters of Pepsi is 2 liters. If I pour it into a pitcher, it's the shape of a pitcher. If I pour it into a large glass, it's the shape of a glass, but it's always 2 liters. The particles are closer together. Kind of think of them as people on a subway during rush hour. The doors open, people get off, people get on. They slide past each other. So it's kind of a fluid. Hence, that's where the thing comes, fluid. They're close together. A solid, particles are very close together, a definite shape and a definite volume. So this book has a definite shape and a definite volume. You can measure both. So you kind of equivalent that as people, putting 20 people in an elevator with a capacity of 15. You can get them in there, but they're not going to be able to move a lot. They're going to be, that's a solid. We can also classify matter by its composition. As a pure substance or a mixture. So a pure substance is a substance that has only one component. A mixture is a combination of 2 or more pure substances in which each substance retains its own identity, not undergoing a chemical reaction. What does that mean for a mixture? If I take sugar and dissolve it in water, can I get the sugar back? How? Do what? Evaporate the water, right. So, when I had the sugar dissolved in the water, did the sugar become anything else? It stayed sugar. The water stayed water. So that's a mixture. Now, the water and the sugar by themselves are 2 pure substances. So pure substances, elements are pure substances. So all the elements are pure substances. And compounds, salt, water, sugar, baking soda, those are all pure substances. So an element is a pure substance that cannot be changed into a simpler form of matter by any chemical reaction. So no matter what you do to lead, you can't change it into gold chemically. You can do it with a nuclear reactor, but it costs far more than the gold is worth. A compound is a pure substance resulting from the combination of 2 or more elements in a definite, reproducible way in a fixed ratio. Quick, what's the formula for water? Okay. If I go to Japan and take a glass of water, what's the composition of the water? Right. So anywhere in the world I go, the formula for water is H2O. So there we have a compound. Mixtures, we have an homogeneous mixture and a heterogeneous mixture. Homogeneous, uniform composition. Particles are well mixed, thoroughly intermingled. Heterogeneous, non-uniform composition, random placement. All right. Favorite food, chocolate chip cookies. Okay. So I have a box of chocolate chip cookies. Does each cookie have the same number of chocolate chips in it? No, I don't care what those little elves tell you. They don't have, okay? Can you see the chocolate chips in the cookie? So you could pull them out if you wanted to. That's a heterogeneous mixture. I have iced tea, which I've don't drink. I'm not from the South. I drink it where you have hot tea, where it's the way it's supposed to be done. Okay. So, pitcher of iced tea. Does the composition change from the top to the bottom of the pitcher? No. So that's a homogeneous mixture. So air, is it homogeneous or heterogeneous? Outside of looking at the slide where it's classified under homogeneous, it better be. You don't want to go from roughly 28% oxygen here, I go 2 steps over and it goes down to 2% and I fall over dead. That would be no good. All right, let me ask you something. You tell me. Gasoline is a mixture of octane, hexane, heptane, 10% ethanol. Is it heterogeneous or homogeneous? I would hope it's homogeneous. I'd hate to see the composition change in my fuel tank as I'm going along the road. Okay. Raisin Bran. Heterogeneous. Okay. 2 scoops. They're always right at the top. By the time you get to the bottom, there's no raisins in the thing. Okay. Let me ask you. Milk. You sure? Are you sure milk is homogeneous? What's it say on the carton? Homogenized. There you go. I mean, orange juice. Oh, right away somebody asked me the right question. Pulp or no pulp? Yes. Pulp. What is it? Heterogeneous. All right. All right. Good group. Everybody's up with that. Okay. This is supposedly showing classes of matter. So here we have a pure substance. This is a mixture. Is this homogeneous or heterogeneous? Heterogeneous. Because you could see more than one. Now, a mixture can be separated by physical means. A pure substance cannot. So, sugar, if I take a cube of sugar and I pound on it with a hammer till it's granulated, what is it? Still sugar. Now, you've all done, well, hopefully you've all done sometime or another, experiment where you have sand and iron filings. How do you get the iron filings out of the sand? With a magnet, yes. So that's a mixture. Did you know you could take total cereal, which has everything in it because obviously it says total, and if you grind it up in like a lunch bag, a plastic lunch bag, you could pull a magnet over the top of it and pull out pieces of iron. Yeah, for real. No, I just make these things as I go along. And if you float it on like milk or that, you can drive your kids nuts. You push a magnet, it'll follow the magnet. Anybody here take vitamin and mineral supplements? All right, if they're uncoated, what do they look like? Are they speckled? Are they speckled? Here's a chewable. You see the chunks in it. All right, so vitamin and minerals. If this was geology class and I said mineral, what would you think of? Rocks. All right, now we're in chemistry class, vitamins and minerals. Guess what the minerals are? Rocks. They're just ground up finer. So there's actually pieces of iron in total, or an iron compound. So where'd you think the iron came from when you took iron supplements and that? Try not to. It's an iron compound in that. Where do you think calcium comes from? A cow. Well, there is calcium in cow, but I mean supplements in that they don't grind up a cow. Shellfish, chalk, limestone. Tums is calcium carbonate, which is chalk and limestone, source calcium. That's where that comes from. Diatomaceous earth are little animals, skeletons of little animals, called diatoms in there. So it's little calcium bony parts of animals. Little, don't make that face. You wouldn't even notice it. You got to look under a microscope to see it. You wouldn't notice it. Physical property versus physical change. Physical property is observed without changing the composition or identity of a substance. Tell me something about this folder. It's orange. Did I change the folder? The fact that it's orange, so I didn't change anything about it. So that's a physical property, color. Physical change produces a recognizable difference in the appearance of a substance without causing any change in its composition or identity. Did I just change its appearance? I folded it. Is it still a folder? So I didn't change its identity. If I take ice, what's the formula for ice? Quick. H2O. I melt it. Now I have liquid H2O. I boil it. Now I have gaseous H2O. Did I change the chemistry of it? No, it's H2O. 3 different physical forms. 2 different changes, physical changes. So this slide here is showing us 3 different physical changes: ice, water, and water vapor or gas.